Okay, guys, so we move over to the linear interpolation technique or the method of false position or the regular fallacy. So you might see this in other uh, books as this method. Okay, so what happens when you try to assume the two guess values? What are the things you need to take note of? Okay, so the good thing about the linear interpolation method, it does not require you to always get the actual root. So this is the actual root, no, or the exact root. I mean, not actual. So let's use the word exact. Okay. So it doesn't need to be in between the two guess values, A and B. So here the guess values are A and B, no? So this is the x1 there and this is the x2 here. Okay? So if it falls somewhere here, dito ka nag-x2, kaya pa rin. Kasi ang gagawin mo, you will try to get this, the equation of this linear. Okay? Meron kang tinatawag na linear representation. So if x2 falls somewhere here, ayan, dito ka nag-fall, x2, okay? Pwede kang kumuha ng point doon, tsaka point dito, and then you interpolate it, or rather, extrapolate na yan, no? Pupunta siya dito. So dito ka pa rin, lalapit ka pa rin. Okay, but of course, the best way is to, again, get values of x1 and x2 that will give you a positive f of x and a negative f of x here. Okay? Okay, so that is at least the best way. Pero hindi siya limited lang dun sa nakagitna. In fact, you call this a second method in the simplest way. Okay? So pag simple lang yung ginagawa mong interpolation, this is known as the second method. A second line is a line that is drawn at the points of the curve. Okay, this is a second line. Pero mas general itong linear interpolation method. Okay? Okay, so what you do is you will now make use of these two in order to get the equation. So you have now a linear equation to solve. Okay, so you solve the equation of this line and then get the root of that, which is very, very near to the exact. Okay, so the technique is to always get the extreme value of your x's within the continuous function. Of course, if the function is discontinuous at some point, you might want to use the point of discontinuity to get the extreme values. Okay? So, isagad mo na, no? Gawin mo ng extreme. It will help, of course, if you know, again, the graph of this function. And this is your f of x. Okay, so how do you get the equation of this line? So, it's simple. No? You have a point here and a point there. So, you just get the slope of the line. Okay, you have a, b, you get f of x. What's the slope of this line? If you know the slope, you know one point, maybe this or maybe that, so you get the equation of the line. And then set it to 0, you get this. So this will be your x3 value. Okay, from that x3 value, you get again that f of x there. So if this is a positive f of x, you pair it with a negative, then okay. So what will happen is you are now what? Capturing. If I extend a second line or an interpolation line from this point up to x2 point there, here, almost I will capture the exact value. Okay, so that's how it works. So again, they are all similar. The bisection method works the same way as the interpolation method, but the way of finding out what is your third point or the new point of reference to get nearer and nearer to the exact value is the one changing. Okay, so for the a comment here, this method is actually just an improvement of the second method, which chooses 2 points at the boundary of the domain. So meron lang siyang kaibahan in the sense na kung minsan you are now using an extrapolation technique to get rid of the error when you choose the two guess values outside the boundaries of the exact value. Okay? Now, for the Newton-Raphson method or the Newton's method, you only need one guess value. Okay? So this is the guess value here. And the next guess value will simply be what? Okay? Determined by, again, a line. Okay? Tangent to that point. Okay? So how do you know this line tangent? The slope of this line tangent is simply the derivative of the function itself at that point. At that point. So again, the target or the objective is similar to the first two, but the way of finding out the next point, xn plus 1, is different. So yung una, hati lang, hati, kalahati, kalahati. Kaya kung minsan matagal, pag malayo ka, paghahati-hatiin mo pa, no? So dito do sa second, lumapit. Dito lalong lalapit 'yan, okay? Kasi mabilis, no? Ang problema lang dito sometimes, pag yung graph mo na naman medyo up and down, okay? Pag dito ka nagpunta and then pabaliktad yung slope, babalik ka doon. So if you encounter two alternately directed slopes, you are actually jumping from one point to the other without really getting getting nearer the actual solution. And one more thing, if the root is not single valued, hindi lang isa yung root mo, you have to have many guess values for the convergence to occur in all the roots. Okay, hindi kagaya dun sa bisection tsaka dun sa interpolation. Pag na-capture mo siya within the boundary, lahat nung nasa gitna na root na yon, makukuha niya lahat yun. Okay. So the Mahler's method is just like the linear interpolation method, but the interpolative function is not aligned, no? Okay, so the interpolation function, if you can see the green line here, okay, f of x here is the blue line, Okay? This is the function. So, yung green line dito is a parabola. So, the only difference between the Mahler's method and the linear interpolation method is that the curve, interpolating curve is a parabola. Okay? So, the interpolating curve is a parabola. So, pag dalawa yung point mo dito, what will happen is this will be your interpolating line, no? Okay? So, kung ito yung root na hinahanap mo, ang layo. Ang layo, di ba? Ang layo nung third guess value mo dito, no? Actually, this must be x1, this must be x2, ito yung x3 mo dyan. No? Okay? Yan. Layo. Pero pag ang ginamit mo is a parabolic curve that what? Interpolates, no? The function itself, you will end up to being very, very near here. Okay, so the difference, one more thing about the Mahler's method is instead of having two guess values for the linear interpolation, okay, so you, in the Mahler's method, you must have three guess values. Okay, so the guess values does not, the third or the middle guess value does not necessarily mean the midpoint of the tree, but of course the easiest way to find a third value is to take the midpoint of the two endpoints. Okay? Kaya dito nag-x1, x2, x3 siya. Okay, so what is the disadvantage of Mahler's method? The disadvantage is it's time-consuming yung interpolation function mo pa lang, mahirap nang kunin kasi parabola siya, di ba? But the rate of convergence, of course, is much faster than the rate of convergence of the linear interpolation technique. Okay? Okay, let's have the fifth one, the last one. There are many variants of this, but these are the basic, the general idea on the method itself. Okay. So if I have here a function g1 of x, so what the fixed point iteration tells us is that we equate x is equal to a g of x. Parang sinabi mo, yung value ng x mo, i-equate mo lang dun sa function mo na ang value rin niya yung x na yun. No? So, pareho siya. This is an implicit formulation. No? So, the definition of the function is made in an implicit manner. Okay? So, parang sinabi mo, x squared plus ex minus 3 equals 0. No? So, you just get x is equal to the square root of 3 minus e to the x. Okay, so this is an x equals juice of x. Something like that. No? Yung unknown mo dito, yun din yung known mo doon. No? So, kung ano yung makuha mo doon, lilipat mo doon. Okay, so it in graphical manner, it simply is doing this. No? The first thing you have to do is to draw a line. Okay, so draw the line y equals x. here. Okay, y equals x. If this is 5, that is 5, then this simply divides, okay, the quadrant, no? And then the next step is to make a guess value anywhere, no? Start with, let's say, this point. So I go up, I reach this intersection on the line. Then I make a horizontal, I take the intersection on the curve. Okay? Then I go up, tingnan nyo ha, vertical, line, horizontal, curve. Vertical, line, horizontal, curve. Vertical, line, horizontal, curve. Vertical, line, horizontal, curve. So, kinapture ko ito yung root mo, no? Okay. So, this is now the root of the two equations, x and g sub x. So, whatever is the value of x here, will also be the value of y there. Okay? Because this is just equivalent. And this is your root of the equation. So if you will start at a point here, let's say here, I get here, then I go here, I go back there, I will fall the same. Kahit saan ka mag-umpisa dyan, it will lead to this root. Okay, you call this a fixed point iteration, and this is a very powerful tool used especially on systems of nonlinear equation. Okay? Okay, so the description of what I did is actually described here below. Okay, so that's it for the basic principles and concepts on the methodologies. So we'll move over to some problem solving situations on the next video.